All right, now you're all going to hate me, but I'm giving you a gift. I'm showing you how to do a complicated chemical balancing problem. Okay? And in this case, the polyatomic ion falls apart. So we cannot count polyatomic ions as a group because they fall apart from one side to the other. So there's another strategy we're going to employ that you can employ in other problems. And maybe you'll like it, maybe not. But you'll notice that the nitrate here, some of them stay together as nitrates, but others do what? Fall apart, NO2. Where'd the other oxygen go? NO3, now it's NO2. Where's the other oxygen? Yeah, it's over here. So our strategy is to try and keep track of what happened. Well, we can tally up how many coppers? Hydrogen, nitrogen, and oxygen, 3. Copper, 1. Hydrogen, 2. Nitrogen, 3. Oxygen, 6 here, plus 2 there, and 1 there, 9. All right. So if you recognize what's happening, you have a polyatomic ion and it's falling apart. You might want to not try and use one of the other strategies, but maybe you'll try this strategy. Okay? All right. If I've got 3 nitrogens, 2 of them here, 1 of them here, that means I had to start with how many nitrates on the other side. How many nitrate groups did I have to get 3 N's on the other side? 3. So this might be a good starting point. Now, remember this formula and this formula. Oh, I did that wrong. Now, these aren't necessarily correct Lewis structures, but HNO3, there's an H and an NO3. And why am I drawing 3 of them? Why am I drawing 3 HNO3s?
You feel like it.
No, I put a 3 in before, remember?
Right.
I said 3 HNO3. So what happens to them? Well, 2 of them stay together as NO3s, right? Two NO3 groups. And one of them becomes NO2. And what's left? Well, H2O. So I've accounted for everything except 1 poor lonely hydrogen, right? So what am I going to do about that?
Share it with something.
I need to add more stuff. What's probably the only thing I can add that's going to make sense here? Maybe 3 wasn't enough. Maybe I should change that to what?
No.
6. Oh, don't get carried away. How many more hydrogens do I need to make
Oh, 4.
water? Change it to 4. I only need 1 more hydrogen, so if I change that to 4, now I got to add a whole nother HNO3, right? How am I going to get water out of this? H2O, and what am I left with? Somebody said in the back there, another NO2. So how many NO2s did I end up with? 2. And how many waters did I end up with? 2. You want to tally up now? Go ahead. How many coppers? 1. How many coppers? 1. That's good. How many hydrogens? 4. How many nitrogens? Careful. 4. How many oxygens? 12. How many coppers? 1. How many hydrogens? 4. How many nitrogens? Let's see, there's 2 here, and 2 here, that's 4. And how many oxygen? We've got 6, 4, and 2. $12. Yeah. Pretty slick, huh? Raise your hand if you're in favor of this method and it makes sense to you and you like it and you think, wow, that's pretty amazing.
I like the other ones better.
Well, now, you don't have to do the drawing of the pictures and circling the products and everything. You can just try throwing random numbers in there and see what happens. I'm just giving this to you as an idea that maybe this will help you.